habits of mind, doing and undoing, building rules to represent functions, and abstracting from computation. So Brenda, give me an example of doing and undoing.
Inverse operations.
Okay. Addition and subtraction with the inverse operations, one undoes the other. Good, thank you, Brenda. How about building rules to represent functions? Ashley, that Ashley.
Yes. That could be like a, or A times 3 C.
Yeah. Something similar to that. And then abstracting from computation, that's a little harder to define, but let me ask a question. If I add 3 plus 2, and then I add 2 plus 3, what do you notice about the answers to that, Rochelle?
They are the same.
They are the same. What property did I just demonstrate? Commutative property. Commutative property says that when you change something, something happens. So, Tim, tell me about the commutative property.
The commutative property of addition means that we can change the order of our numbers that we're adding and still get the same answer.
How many numbers?
2, at least 2.
At least 2, 5 numbers.
As long as you're doing all addition.
As long as it's all addition. Good, all addition. So that property, that commutative property, that did not come down from heaven like manna, you know? After years and years and years and years and years and years, I did years and years and years of people adding and getting the same answer no matter what order it was, they finally decided it's going to happen every time, and I'm going to call it the commutative property. So they abstracted from a lot of computation. Okay? All right. So then we talked a little bit about the order that you should teach in. You always begin with the concrete when you have a new concept. Then you go to the pictorial, and then to the abstract. Now, abstract are symbols, words, algorithms, all the things that Dr. West was trying to say earlier. I have a Dr. Brown at my campus. Oh. And she's a good friend of mine. So, yeah. So, what Dr. West was saying, they want you to teach the way we used to teach a long time ago when I was little, and I just memorized things. You know? That old thing, you know, to divide factors, don't ask why, flip the second number and multiply. They meant it. Don't ask why, just do it, okay? So that's very abstract. We don't want that anymore. We do want to teach critical thinking. I don't care what whoever he is says that we don't. We do want to teach critical thinking, and to do that we need to go through these steps, okay? One way to do that is to use multiple representations using manipulatives. Oral or written words, which is abstract. Symbols, which is abstract. Pictures, diagrams, tables, and graphs, those are all pictorial. Okay? And then we worked on fractions, and we loved it. It was so much fun. We did an area model with pattern blocks. We did a linear model with a number line. And then we didn't do a set model, I don't think, just because we didn't do a set model. Okay? This was the pattern block problem. Remember it?
Yes.
Yay! It was so much fun. So much fun. So 1/2 divided by, this represents 3 halves. Because 1/2 in pattern blocks most of the time is the trapezoid. Because 2 trapezoids make this hexagon. This happens to be a regular hexagon. And so 1/2 divided by 3 halves. And we worked on that and we modeled it with pattern blocks, remember? Okay. And then we modeled it with number lines. Coming back to you? Okay. And then we did these great problems with pattern blocks. Okay. So, and then we did this. We, the third algebraic habit of mind, we created a function from working these problems, and we did it with triangles, we did it with squares, parallelograms, trapezoid, and hexagons. Okay? So do y'all remember the patterns that we found? Think for a while? Yes, sir?
They always had a +2 at the end, I think.
And why was that? It was a linear model, okay? Well, an area model, but in a linear formation. Why was that +2 at the end? Craig?
It was the ends of the tables.
Okay, the ends of the table, so here and here was a constant. Good word. And the other part of the function varied depending upon the shape that you were using. Okay, great. So today, and then we had to make our chart paper. You know, I almost always have you make some kind of chart paper, okay, where you represent your findings, much as you did with Ms. Laura this morning. So then we thought back, you know, what did somebody who might have just walked in the room, what would they think? They would think it was pretty chaotic at times, but you were on task and learning, all right? And then I get a little preachy. That's the same thing I just said a while ago, which I'll probably say 1,500 times today. So then, here's the question. Why did I ask you to illustrate your process on chart paper, and why did Ms. Laura ask you to illustrate today on chart paper? Now think for a minute. What do you think, Pam?
For visual learners?
For visual learners, that's good. Jen?
We all had different, well, not different perspectives, but different ways of saying somewhat the same thing, or we found errors, sorry, within the groups and were able to communicate about it.
Okay. She
But-
said two things.
It's, I really want to do it this year, but I keep saying that, it's just.
You're gonna do it this year. So she said two things. One is, when you see other people's work, you learn from that and you add another tool to your tool belt. And then if there's an error, you learn from that. What was Rochelle telling us this morning? About the dendrites?
Mistakes.
Mistakes are good, aren't they? That's a learning situation. So you should use it for a learning situation. And that just says what we just said. See, I get really preachy and I keep saying the same things over and over again. So we're gonna go on.
Say it 3 times mistakes.
Maybe so. Maybe so. And then we talked about tables, because you had to make a table on your chart paper. So this is an example of a table. So we're talking about the number of dogs and how many eyes would be on this many dogs. Assuming they're normal dogs and they have all the eyes they're supposed to have. Okay? So one dog would have 2 eyes. 2 dogs would have 4 eyes. Where's that little green button? Oh well. So you can do that either by 2 plus 2 or 2 times 2. So 3 dogs would be 2 plus 2 plus 2 or 2 times 3. And then we noticed something about multiplication and addition and their relationship. Remember what that was? Tanya, I looked at you, I'm not going to call on you. But do you remember what that was?
I'm sorry.
The relationship between addition and multiplication.
It's up there.
Your science, so I kind of.
No, I know. But you're asking if I remember what it was, and no, I don't remember what the. No, I actually don't remember what it was. I'm trying to figure out what you're asking me, but I don't remember.
Okay, all right. So math person, who might remember? Maybe.
What was the question again?
What's the
Well,
relationship between addition and multiplication?
Repeated
Oh,
addition?
Michelle?
Oh.
Repeated addition?
Yes, multiplication is actually just repeated addition. That's all it is. Yes, multiplication is really just repeated addition, and some very wise person, probably, I don't know, a woman maybe, said, you know, instead of writing all this out, I could write it like this. Right? A little shorthand, a little shorthand. And honestly, I don't know who did that, because a lot of the mathematics that was developed, we don't have names to go along with who did it, like the properties. Who told us it was commutative property? I don't know. I have
So
no
would
idea.
you say grouping, like group all the 2's together? Or would you
If you
say put the, what's it called, common or like
Like
terms?
Yes, if you
So
had
just
different
say like
numbers.
terms.
Yeah, but those are all 2's. But if you had some 2's and 3's, then yes, you would have to group your like terms.
Okay.
Okay, and then we notice some patterns in the table. Thank you, Jim, for bringing that up. So when the patterns are going down, this is the first kind of pattern that students and teachers learn. It's going down the table. What's the name of that pattern? What do we call that type of pattern? It's Tanya?
Recursive.
Recursive. That's a recursive. So, it's right there, Jim. So to get to one number, you have to know the number right before it. So to get to 1,000 dogs, I have to know how many eyes 999 dogs have. So we don't want the kids to stay there. We want the kids to be able to rate it across the table. I say relate it across the table, like this. So what kind of rule is that? It's up there.
Down the bottom.
It's an explicit rule where we don't have to know how many eyes 999 dogs have to get to 1,000. We can use our rule. Okay? We can use our rule. So this is all review. The people who are just here, they'll print out this PowerPoint eventually and give it to you. I don't let them give it to you ahead of time because the answers are in it, and I don't want y'all to know the answers yet.
Are we gonna get it this time?
Eventually.
I was gonna use the pattern one when I get it started.
Yeah, you'll get it this summer, just not today, okay?
Oh, no, that's fine.
All right.
So,
So, yeah. So here I am again, manipulative pictorial algorithm. See, I'm very, all right. So here is the new part. We are still going to work with fractions and kind of tie up fractions. Yes, ma'am.
Just to make sure I understand, with math, the concrete are the manipulatives?
Yes, ma'am. Anything they can touch and move.
but it can sometimes be.
After the manipulative, then they go to pictorial.
Right.
Then,
On your table, and I'm not suggesting you look at it now, but you have a copy, a master copy. So this is the same as the ones that you have in your own notebook. These are for your easy access right now. And there is a handout on concrete to pictorial to abstract, and it gives examples of what that would be in both math and science. So whenever you're ready, I can find it.
okay, well, let's back up then. Concrete is usually something that they move and touch and do. And after that, then you go to pictorial. Now, if you're teaching 8th grade and your teachers before you have used all of the manipulatives for a certain concept, when they first initially began teaching that concept, your kids may be ready for pictorial. Okay, so this is generic, you know. I think in the first slide I had this on said when you're teaching a new concept, it's manipulative. Right? Okay. So,
And actually, in science, we say, in general, remember, not a law, but principle, in general, your lesson, a lesson should move from concrete to pictorial to abstract. That's a little bit different from what Browning just told you for math. So,
yeah, there's no in general in math. It should move from concrete to pictorial to abstract. Now, some things, order of operations is really difficult to find manipulatives for. I've not found one ever. When you find one, let me know. The order of operations, you can look in that book, but there's not really a manipulative for that. All right, so moving on. We're gonna finish up with fractions today and then go to functions tomorrow. All right, so you have some Cuisenaire rods at your desk. If you would open those Cuisenaire rods.
The thing is, science people, we're all like about the science, but these years, I'm like,
not yours.
There's a
Feel better. I have a headache.